You're on, please, Patrick. Yeah.
Okay. I thought I'd show you guys the project that I worked on in spring quarter because it's pretty similar to what you're going to be doing for your final projects. And so hopefully you guys can use this as a sort of example presentation for like what kind of content you should have in your presentation, and maybe give you some ideas on how you can structure your code and how you can structure, I guess, the flow of your presentation. I'm probably going to skip over most of the music theory background and just kind of focus on the ML side of it because I think we've covered a lot of the music theory stuff already. But yeah, I guess I'll just start walking through this then. So basically, the motivation for my partner and I doing this project is that we're both musicians. We enjoy like doing soloing and playing like blues and jazz and stuff. And so we wanted to create a tool where musicians can input a chord sequence and then get a solo that they can practice in order to improve their improv skills. And we wanted to avoid some big things. We don't want to like replace musicians with AI or anything. We don't want to like, create AI music necessarily. We want to create tools that musicians can use in order to improve their own skills. And so, yeah, basically, then we kind of discussed some of the very, very basics of music theory, so like chords and scales, but we've already gone over that to some extent in this class. And the audience for this particular presentation was people who had no music theory background, and so we decided to include all this just to make sure that everyone was on the same page. I will say though, for jazz in particular, jazz songs are generally structured around a chord sequence. So you have like a sequence of chords, like in Autumn Leaves, for example, you have an A minor seventh, D seventh, G major seventh, etc., etc. And initially a melody is played over the chords, and then it's followed by a solo section where the chords are repeated while musicians take solos over them. And during the solo section, there are certain scales that work very well over the underlying chords. And that's just kind of like a jazz music theory thing. You have a lot of different scale modes that you can use, and some of them work better with certain chords because they have common tones with the chords, or they have common tones with like the grouping of chords in a particular like section of the song. So it might bleed over from one measure into the next and kind of bridge the gap between two different chords very well. And a little bit of the history of bebop and the artist that we use to train our model, Charlie Parker. He kind of pioneered the subgenre of jazz in the 30s and 40s after the swing era. It was very much like musicians' music because it was focused on like super technical, fast playing, fast chord changes, fast licks, just a lot of focus on the technical aspects of music. We thought it was a pretty good subgenre to pick for this project because we could hold the rhythm constant and really just focus on the note choice, focus on making sure that we create some sort of interesting melody generated by the computer. There are some previous works. One second, let me share computer sound. There you go. There's a lot of people who have tackled jazz solo generation. In my partner and I's opinion, we thought that a lot of these models tend to like sound computer generated, and a lot of these examples also generated harmony under the melody. So that's just an example of like previous works. Here's another one. So the big failing that we saw with this sort of music is that there wasn't a whole lot of music theory incorporated. It wasn't it was more an experiment in like trying to generate some kind of music with AI rather than trying to generate like music that people could listen to. And so we did want to understand what a lot of these previous examples are using, though, so that we could kind of incorporate some of their techniques into our own model. And so a lot of the previous work that we studied was using long short-term memory networks, because they're able to predict new notes given the previous notes played. So it's sort of like a feedback loop where it makes a prediction and then feeds that prediction into the next cycle of the machine. And so it continually like remembers what was previously played in order to inform what it should play next. Convolutional restricted Boltzmann machines have also been used to impose further constraints like tonality and rhythm, and that's something that we eventually want to experiment with. But it's a little bit more complex than an LSTM network or the network that we used, which was a generational recurrent unit model. We initially tried LSTM implementations for it, but our melodies usually converge to just like playing the same note for like 16 bars, which is not what we were looking for. So we switched to a sentence generation model. So GRUs are used a lot more commonly in sentence generation. It's similar to an LSTM network, but it has a forget gate. So it allows for slightly different possibilities with the way that it like remembers previous notes and stuff like that. And we thought it worked a little bit better for rapidly changing chords. And we thought that it was a pretty good model, especially for our limited data set, because it tends to do better than LSTM with less data. And so the data for the data set, finding clean data was the most difficult part of the project, like just finding and parsing all the data. So we ended up grabbing, I think, 30 Charlie Parker solos, transcribed from the Weimar Jazz database. They had MIDI, but the MIDI was not quite working in terms of the timing. And because the timing was important to us, because our input to our train network is a set of chords with timings, we wanted to find we wanted to find something that represented the timing better than MIDI. And so the Weimar Jazz database had some CSE files with numbered timestamps for every downbeat in the solo. And then it also had the solos with the timing of each of the notes played and the duration. And so this worked a little bit better for us, and we were able to parse all of the data using Music 21, which I think you guys have been working with for at least at least the homeworks. And we limited our pool of solos just to Charlie Parker solos, just so that we can kind of more easily hear whether the model was successful. And so as far as encoding the chords and scales, we used relative scale degrees to encode the chord scale relationships. So every single chord that was inputted was in terms of the song's key. And that way we could kind of abstract everything to numbers rather than having like specific notes being labeled. So instead of a major seventh, F seventh, B flat seventh, you have 1 major 7, 6, 7, 2, 7. And then the same thing applied to the scales. So we had the numbering in terms of the root, so that we could transpose it into any key without having to worry about having to like change the scale in some way. As far as the network architecture, just to discuss the mechanics of a GRU a little bit more. It's a newer form of RNN. I believe it came out in 2017, and it allows for networks to remember more because it has a forget gate, which sounds a little bit counterintuitive, but basically, like, the forget gate allows it to forget irrelevant information, and so it's able to remember more relevant data, and that we think ended up having a better solo model being generated. And so you can kind of see the general structure of our model here. Basically, it takes in the previous prediction, as well as the note input into the hidden layers, and then after the hidden layer processing, it would restrict the notes in a final fully connected layer, and then output. Whoops, this should actually be Y. It would output the note, and then its input into the next time cycle. And here was the initialization code that we had for this as well. And so you can see this was using PyTorch. I'll go a little bit more into the code after going through the slides, but basically we had the input size, the hidden layer size, and the output size. By default, those at least the number of hidden layers was by default 1, and we didn't change it for the example that we generated. And yeah. So as far as the results, as far as the overall sound quality, we thought that it sounded pretty good. And maybe one of the main reasons for that was because it always adhered to the music theory rules we laid out. Using the sentence generation technique made it more natural sounding. It definitely was less repetitive as well. But we had some pretty simplified rules. It didn't take into account like the next upcoming scale or the next upcoming chord, or like previous scales or chords used. And so those would be things we want to incorporate in the future. But we can just listen to it. There is a set of jazz chords called rhythm changes, and it's based on George Gershwin's I Got Rhythm. Basically, a bunch of jazz writers took the chords from I Got Rhythm and wrote new melodies over it. And so the rhythm changes have sort of become a jazz standard sort of thing. A lot of actual jazz standards are all using the same set of chords, the rhythm changes. And so we inputted rhythm changes as our chords for the trained model, and this is what it generated. embellished it a little bit. We didn't actually input it into some sort of MIDI software because, again, the intent for this tool was that musicians could use it to practice. And so we recorded a backing track to play over, and then I just recorded like just reading the notes, and replaced the 6 repeated notes down here with a little 16th note run just to liven it up a little bit. But again, we held the rhythm constant so that the main demonstration of the model would be the note choice and incorporating the music theory rules. And one super cool thing that we thought was awesome to come from this is the fact that it generated the lick. So for those of you who don't know, the lick is a jazz meme. I think you guys get the picture. But basically, it's a jazz meme. A lot of jazz musicians have used it in their solos, whether intentionally or not. These days, I think it's more intentional because it's a sort of more well-known thing. But our model ended up generating the lick in the middle of our solo, which we thought was like absolutely mind-boggling because it became a meme because of how prevalent it was in real jazz musician solos. Like everyone used it and it grew popularity that way. And so the fact that our model actually picked up on it was really awesome to us. Anyways, as far as future work, we want to kind of apply more sentence generation tools to kind of make it sound more natural, have some sort of prediction on like where it should go. So again, like taking into account what chord is upcoming in order to inform what scale it selects now, and looking back maybe even further to have more coherent like chord scale matching. So maybe selecting a single scale for multiple chords so that it can kind of sit on this one harmonic sound for a few bars and kind of experiment with it. We also want to just generally add more complexity. We limited the scope of the chord variations to just like 7th chords, essentially, like major, minor, and dominant 7th chords. And we only had a total of 15 scales, and there are so many more. And so just increasing the amount of complexity in the music theory rules, increasing the solo transcription pool, increasing the amount of genres that we use, and the amount of musicians that we use for the training data as well. And then, yeah, that's pretty much it. And hopefully this gives you a decent overview of like what your presentation can look like. You probably don't have to focus as much on the music theory stuff because this is a music class after all. But let's take a quick look at the code as well. So this is our GitHub repo. The kind of most interesting 3 files here, I think, are the model definition. So basically, this is like the initialization and our custom definitions for the forward pass of running through the model. And then we also have our generation file, which would take the train model, and you can see here we have all of the rhythm changes defined. And so we went through each half measure and assigned a chord to the final like fully connected layer so that we had the note restriction as it was making its predictions. And so then after all of these were defined, it would run through the whole network and make predictions and generate our solos. And then as far as the training of the network goes, we pretty much it was a pretty standard like training method. We took a random training set from the pool of solos, and then we went through them and trained them, and then validated on other solos. Yeah. Any questions or comments?
So first of all, thank you so much for this great presentation and great example, and also the results are really convincing and musical. Yeah, any questions from the audience? I have a couple of questions. So
Okay.
all right. So I think this is super interesting. I mean, the idea that in order to produce interesting or musically valid results, right? You incorporated some of the musical knowledge in it. And I think this whole topic of, sort of combining statistical or stochastic or whatever methods, machine learning methods with some existing knowledge. I think this is really something that is a growing, I wouldn't say concern, but interest in research, right? Including transformers now are combined with some knowledge graphs, Transformer XL, and trying to use like language models with some additional, maybe more traditional grammatical structures and rewrite rules. So my question would be, how would you, when you want to, usually the examples we showed for the RNNs or GRUs, STMs, you seed it and then it basically feeds on itself, right? It takes the past. And, in this case, it was really constrained on the structure, and we spoke about this, the idea that you can either query or kind of like lead, have this specification of where the prediction will be. So can you maybe show us, I mean, how would you input the code changes or the lead sheet? Or
So I think our intent for this is to eventually make it into like a fully fleshed out either app or website or something with a real UI. And
right?
so it would be kind of similar to like maybe online music notation software where you instead of inputting different notes from a measure, you would input like chords, and so you would put the root and you would put the modifier into this UI. You can add as many measures as you want, and then you press the go button and it would parse all of the like UI elements of, okay, here's all the chords that were inputted, and then send that into the network in order to generate something.
So in the slide that you show the GRU architecture or in the code, so your input file actually was a sequence of chords, right?
So for generating after we
cell,
trained the
yeah.
model for generation, we hard coded all of these changes. So you can see like which half measure corresponds to which chord. And we just hard coded the entire rhythm changes in order to generate like a particular example, because we felt familiar with rhythm changes. But eventually we
So
want
if
to
you
like
wanted to have it,
this.
So I mean, if you wanted now to input a different one, you can actually create some kind of an input file format that will read this, right, and input this into sort of a branching structure with ifs or graph or something like that, that will actually tell you, or just a sequence, right, of these restrictions. I mean, am I interpreting this correctly? Yeah.
Yeah, it would probably be like measure number and then beat number and then the chord, and interpret it that way. And so based on wherever you are within the song for predictions, it would like reference what chord is there, maybe what
Mhm.
chords are before and after, in
Right.
order to make the predictions.
So, just to wrap up that question, uh, how much, I mean, this knowledge, this restriction, there's this notion of implicit bias in the modeling, right? Where the network itself, even though we kind of seem to be doing very kind of general statistical modeling and input output, but by deciding what is the architecture of the network, what is the representation, and maybe adding some extra rules, we kind of still encode, we bias the network towards specific genres, specific styles, constraints. So how much of a musical knowledge would be required to input, let's say, um, a new lead sheet instead of chord changes to take another song? Um, you would need to know the chord progressions, right? And
Yeah, that
and that's it, right?
just like the song key and the chords.
Mm-hmm. It just is a sequence, right?
Hmm.
Great. Okay. So yeah, so this is really interesting because it kind of makes total sense. They kind of transition very fluidly from one bar to another one, from one chord to another one.
Yeah.
So so there is something interesting going on there, definitely. And about the lick, so you trained it on Charlie Parker, right?
Uh-huh. The lick was not present in any of the solos, by the way.
Really?
Yeah.
So
It
how,
was
how so that was my question. I was asking, was it present? If not, how do you think it generated it? Where it came from?
I I think it's just it's a phrase that can work in a lot of solo contexts for jazz. Like sort of it works for most chords and most keys. Like you would sort of have to change where it starts, but that pattern, like there's a reason why it's become a meme. It's super easy to fit into any solo, and so
So it just emerged through that
it
random
just
learning?
it learned this human like jazz um almost stereotype, like
Interesting.
which that's why it was so cool for us.
Yeah,
um
okay. No, it's interesting. Yeah, that's what I was wondering. I mean, did it actually learn it from examples or it sort of had its
yeah,
own
it just put it together on its own, um
cool.
based on the record restrictions, based on the inputs, I guess. It just somehow it happened.
Nice, very nice. And then if we wanted, yeah, we just have one more minute and then
Mhm.
um, uh, allow myself to ask another question. Uh, if if you wanted to learn a style of a different musician, you will basically so you think that this improvisation, right? Besides being musically correct, uh, so it follows the rhythm changes, the chord progression, um, and it learned interesting phrasing, and then the lick emerged. Uh, from your familiarity with jazz styles and improvisers, do you think, would you say that in some sense it's typical, or how close it is to Charlie Parker's style? And what would you do if you wanted to imitate, some other musician, if
I
you wanted?
think it's sort of hard to tell whether it's like Charlie Parker style because there's there's no rhythm
Okay.
constraints, and so
Hmm.
that's sort of like the next major thing for us is not only having it do note selection, but rhythm selection, having phrasing, and the end of sentences and the beginning of the next one, sort of thing. Charlie Parker, I think one of the most impressive parts about his soloing is that he has like these very particular ways of phrasing his licks, and so you have like maybe different runs, you have the use of silence, um, and I think that's the thing we want to try and focus on next. Now that we have at least the basics of like note selection
Hmm.
down. Um, and so I think for learning any jazz musician style, a lot of it is found in the way that they phrase things. And so we
Yeah.
sort of have to implement phrasing in this tool before I could really say whether it's an accurate reflection of someone's style. But
Hmm.
at the very least, with note choice, like I think it sounds pretty close to the kinds of notes that Charlie Parker would pick over rhythm changes. He has a few solos where he plays over different variants of rhythm changes, and um, we had a version of the network that actually spit out the scales that it used in each beat,
Hmm.
and comparing that to the transcriptions for some of his solos, it was like a lot of the same scales were being used, and so we thought that was pretty cool. Of like, it was
Nice.
actually sort of picking up on what Charlie Parker was doing harmonically in the context of the chords, and so
So
as far as the note selection, I think it's a pretty decent
mhm.
reflection.
Interesting. So you could basically derive the chord scale kind of relations, which would be Charlie Parker or artist specific, at least to some extent.
Yeah.
Are you familiar with the work of Bob Keller from Harvey Mudd? He has the improviser software.
No, I don't think so.
No. Okay. Yeah, I can send
Bob
you the link.
Keller.
Bob Keller, or Robert Keller. Okay, he's a professor in Harvey Mudd. He has this improviser. It's like improvisation advisor. So he actually models things with grammars. And he has this huge collection. It's a software, and basically it comes with choices of he encoded by hand music-specific grammars. You can see how elaborate these grammars become. So, and just because you mentioned, these types of applications that would be of interest. I mean, we were actually talking about sort of like mix
Oh,
again between grammar representations and machine learning, and he had some work done, and also the
I
yeah.
I've actually come across
Mm-hmm.
his page of like jazz resources.
Yeah.
While we were looking for data sets, I was looking
Mm-hmm.
through a lot of his like transcription links.
Mm-hmm. Yeah,
But
and he's very
I
much
have come
inspired.
across his work.
Yeah. So, yeah, so I mean, like he actually was a visiting professor last year in our
That's
department.
awesome.
Yeah, I mean, if that's a connection to explore really. And I know that he's very much influenced by the, I don't know if you know, the bricks theory, which basically chunks chord progressions into sequences that are called bricks. So I mean, there are several different interesting approaches, and the fact is that it's very hard to formalize jazz. Right?
Mhm.
Um, so yeah,
The
no,
Lego bricks
it's
method.
yeah, the Lego bricks. Yeah, yeah. Great, very interesting. Thank you so much. And on Monday, we will kind of touch base about stuff. We don't plan to, I think we postponed and give you a little bit extra time to start the presentations from Tuesday. So yeah, let me stop the recording. And again, thank you, Patrick.